All right, ladies and gentlemen, it's been a little too long since the last time I made a video. I think it's been probably over a month since I recorded a video. You might notice I'm in a new setting, moved, and yeah, a lot of stuff has changed. But in this video, I want to talk about 5 things that I've learned from really the past 2.5 years of smart contract security. Like, if there's only 5 things that I have seen that you should do to secure your smart contracts, then it's these 5 things. So it's going to be hopefully a quicker one. I'm sure it will probably get a little long, but just want to share these 5 things so that hopefully, if you're developing your smart contracts, you can have these in mind and hopefully try to implement them so that when you do actually go for a security review, then hopefully it can be a lot more productive, and it can, in most cases, be a lot cheaper if you've actually put these in place. So, of course, before we dive in, my name is Owen. 2022, I co-founded Guardian, and fast forward 2 years. Today, we're industry-leading smart contract security provider. We've uncovered and prevented hundreds of critical vulnerabilities from entering production. We've audited dozens of high 8-figure, 9-figure TVL DeFi projects. And the reason I make all of these videos is ultimately so that you can ultimately become a highly skilled smart contract security researcher, and maybe one day hopefully join the Guardian team. And maybe if you're a protocol developer, then when you come and work with Guardian, hopefully you've put in all of these best practices that we talk about in place so that we can have, as productive of a review as possible, so we can take you from, where you are already, hopefully at like 80% of the way there, to the final 20% to get you to launch smooth with no vulnerabilities and have very seamless experience. So with all that out of the way, let's talk about these 5 things that can maybe help you get to that 80% of the way there, and hopefully ideally save a ton of money in security costs and obviously save from any hacks in the future. So let's get into it. All right, I'm just going to dive in. Let's talk about the 5 things. So first of all, this is probably the number one thing that gets most protocols, and this is what you'll see is, usually the crux of, or at least involved in many exploits, is just external calls. So we want to be anal about our external calls, right? So, I mean, even when you're ready, you think you've got everything ready, it's down, it's ready to be shipped off for an audit. Go and just grep for all of the external calls that are being made and just step through each one and think about a few things, right? I want you to think about, obviously, reentrancy risks. Think about denial of service. Let's say if it just reverts, is that bad? Go ahead and think about gas griefing. So if it expends a ton of gas, is there anything that's going to be bad? Is it going to be able to cause the person who's calling that function to have to expend a ton of gas? Could it potentially cause it to overflow the block gas limit, and then by way of that actually go over the basically become a DOS attack because you can't execute it? Or have a look at the return values, the return data that gets returned. Are you parsing it? Are you expecting any? And then what are you doing with it? Could that ultimately, in some cases, cause a DOS? Could that just be completely unexpected values and that cause something, right? So really focus in on all of the external calls, specifically the untrusted ones that are to, ideal if you have any that are to an untrusted address. Really go through, think about each of these 4 things. And if you can, try to separate out those external calls into separate transactions. For instance, something I see time and time again, which pretty much always leads to either a gas griefing or a DOS attack, is when one user is calling a function and there's some kind of arbitrary fee recipient that is maybe not controlled by this user, and they just get called, like an address payable fee recipient dot call with some message dot value or something to send them ether. The issue with this is that you're going to call them, they're going to be able to revert, they can DOS, they can expend a ton of gas and take that from the user who's executing the transaction. No bueno, right? So just separate that ideally into a separate transaction. You can have a mapping that stores like, hey, here's how much fees this address has accrued. And then they can come and pull those fees from the contract in a separate transaction, right? So separate those out. Be really anal about the external calls that are made. Consider all four of these things. Great. So we've got number one covered here. Let's talk about the very fun feature of inheritance. I really don't like inheritance, specifically as a security researcher. I can tell you how many times there's been a contract here that inherits from something, like let's say it inherits from Open Zeppelin ERC 4626, and it's overriding some of these functions from ERC 4626, and it has some specific functionality there because it needs to implement some features, but it forgets to override one of the functions that's still an ERC 4626. Like they've got mint, redeem, withdraw, all these different stuff. So the risk here and why this creates such just an additional surface area to cover in security reviews is you've got to be very, very careful about, hey, what functions are being overridden, what storage variables are in the parent contract, what functions are you still able to call that maybe you didn't want to be callable. Stuff like this, inheritance just introduces just another dimension of risk surface area. And it just makes the system a lot less readable. And sometimes, especially if you're inheriting a lot of things, it's hard to even figure out if I call super, which one is he even going to? And then you have to think about C3 linearization, which is how Solidity figures out which one of these things to call. And it starts to become kind of a mess. And so in my opinion, just from a pure security researcher's point of view, I really don't like inheritance just because it makes everything less readable. It introduces all of this extra surface area for potentially forgetting to override a function or something like this, having some blind spot here because it's in a different contract, but something in that contract can ruin something in this contract, etc., etc. For that reason, I don't like inheritance. And ideally, if you would choose not to use it, I would be happy with you. So that is number two. That's my reason for not liking inheritance. And then number three is simply to write less code. And this one is like really core, really near and dear to my heart. Like, please stop writing code. Like, if you have like a simple, relatively simple protocol and you're coming up on the 2,000 line solidity code mark, like maybe reconsider. Maybe go back to the drawing board. I would say that most simple smart contract systems can be implemented in around 1,000 lines, maybe 1,500. So if you're coming in with a staking app and it's like 3,000 lines and it's like staking for rewards for your reward token, like, bro, try again. Like, like seriously, this is the one like magic pill. Like if you just write less code and just write it more succinctly, still in a readable way, it doesn't have to be, anything crazy. If you just architect it well, then you're going to spend way less on security reviews. And, like we'll be happy to charge you less because it's way less work for us. And you're just going to risk a lot less of, a probability of a hack occurring. So just write less code. All right, number four is going to be to bottleneck external functions to only the necessary ones. So this is, maybe tangentially related to writing less code, but we want to be very explicit about here are the things that we need users to do through the front end, right? And then those are the external functions. Do not make superfluous external functions because you're introducing literally a quadratically increasing surface area of attack vectors. Because for every external function that modifies state that you add, now you've got to think about, and we've got to think about, all of the other state transition functions that are there in the contract and think about, hey, what if we use this function in conjunction with this function? or this one in conjunction with this function. And we've got to look at all those. How does that affect the state of the contract? And so ideally you have like 3 external functions that change state, right? And that's your application. Those are the 3 state transition functions that matter on chain. That's all you have. So as much as possible, I would encourage you to remove obviously any superfluous functions and try to even just bottleneck down the specific actions that you can make through your smart contracts to just a core set of functions that are allowed to change states. In this way, we're just going to remove the modularity of different attack paths that are available to people who, would be trying to cause some expected state. And you're going to remove a lot of the tools that we use as auditors to be able to get interesting vulnerabilities to happen. And finally, number 5 here that we're going to talk about, to move extra logic off chain. What do I mean by this? I mean, if you've got logic that is not mission critical to the state that needs to be stored on the blockchain, and it's not related to mission critical validation that needs to happen, then honestly, it should be moved off chain. What's an example of this? Let's say you have like a liquidity protocol and users have positions, right? You have a position where you've provided liquidity and there's a certain amount of liquidity for your position. Well, the liquidity amount is untenable to a user interacting with the protocol. So you say, I want to make it so that people can pass in 100% to specify that they want to remove 100% of their liquidity. And then what your smart contracts are going to do, they're going to interpolate that 100% value. They're going to turn it into a liquidity amount, which is 100% of your position's liquidity or 75% of it or what have you. And then it's going to continue on with the logic of, removing your position liquidity. That is superfluous logic that doesn't need to happen on chain. It's just introducing more lines of code in your smart contracts, which are the most vulnerable and the hardest area to secure. More opportunity for bugs to come up. Is an added layer of consideration for testing. Now in every test or any invariant suite that you make, you're going to have to think about that interpolation. And it's going to make it hard to read and assert things on positions. It's just not a great idea. So leave the ease of use type stuff like that to the UI, or if you really want to make a separate repository, a separate set of contracts that are like your periphery contracts that handle that stuff in completely separate logic, so that the core is the core and it just does what the core needs to do. And it can be very highly secured and it can be very stripped down to just exactly what's necessary. That is it. Those are the 5 things. If there's any 5 things that I would think about as you're going through the development process and bringing things closer to the launch date, or when you're planning on launching, think about these 5 things. Go through them. Continuously remind yourself to be anal about external calls. Try to avoid inheritance. Please, for the love of God, stop writing code. Try to bottleneck the external functions to only the ones that are necessary for the application, and then remove all the superfluous, ease of use logic off chain. That can be a front end thing. That can be a periphery thing. Do these 5 things, and I promise you will save tens of thousands of dollars in your security reviews, and you will save, honestly, weeks or maybe even months of time when it comes to actually getting your protocol out the door in a secure fashion and having a successful launch. So those are the 5 things. I hope those are somewhat valuable for you, and I hope you're able to take some of these and implement them. Of course, if you'd like to work with Guardian, go to guardianaudits.com. We're happy to take you from 80% of the way there to 100% of the way there and get your protocol safely launched successfully. And then, of course, if you're a security researcher and you want to join a world-class team and really work on the crux of the issues that really plague the Web3 security industry, and you want to work with some of the most inspiring protocols and projects in the space on some of the toughest security problems, then go ahead and head on over likewise to guardianaudits.com and click the Join Us button if you're looking for any open roles. So that is all for this time, and I can't wait to see you in the next one.